Good afternoon, everyone. This is Chandana, Assistant Professor, Department of CSC, Mlritm. Let's learn about Armstrong numbers from here on. What's an Armstrong number? Given any number, if the power of the number of digits in the number and the sum of them digits is equal to the same number, then it becomes an Armstrong number. That means first, when we want to find out whether a given number is Armstrong or not, let's find how many digits are there in the given number. As I have 3 digits, I will be doing the power with 3 for each single digit in the given number. Okay, and add all those to get the same. Let's see, are there any Armstrong numbers? If yes, and how to find Armstrong number or not if I have the given number more than multiple digits. See here, I have taken an example where I have 4 digits in the given number. So my n value is 4. Okay. Then I do the power with 4 because my n value is 4 for each digit in the given number. And then when I do the addition of them, I have to get same. Then only this 1634 is called an Armstrong. Now see here 123. 123 is the given number, but here number of digits are 3. So n value is 3. I will be doing the power of each digit in this number with 3. Then I will add them. I got 36. Is 36 equal to given number? No, that is why 123 is not an Armstrong number. Okay. Let's see the logic for this. So my input would be, I will be giving one number, and then analysis input is, as usual, we will be giving the value from the keyboard or initialization, and I am mentioning the number to be n. My output is not any value, no value, but it is clearly telling that whether the given number is Armstrong or not. The logic is, first we need to count how many digits are there in the given number. Then we have to separate each digit from the given number, do the power of that digit and add them to the next one. So it's looking little tough and clumsy. I'll make it very simple with the basic mathematics what we have learned earlier. Okay. Let's take 1432 as a number. That means my n value is 1432. Count should be equal to 4. But how will I count? I'm able to see the number and I'm able to tell that it is 1432. But critical thinking, that is how computer will be able to count 1432 as 4 digits. Actually, how would we read 1432? Even we have trained the computer also to read it as 1432. It is actually 1432. Even the system reads like that. But it should read it as 1432, individual digit, so that it counts to be 4. Okay. How should we do that? Now see, very basic previous explanation. I hope you know about units digit, tens digit, hundreds, thousands, these places we learned in our kindergarten. So that would help us here to learn the logic behind this. This is your ones place, tens place, hundreds place, thousands place. See this, there is in every space I have incremented with 1 0. Additional 1 0 is going on. This we know from our kindergarten. Let us place our number 1432 below this. Okay, 1432. As we have read it as 1432, this is 1432. I hope you understood this. Now I have to count the digit means I will be counting from zeros place. System always need to count it not from this hand to this hand. It will be counting from this hand to this hand. That is because zeros place is called an orphan place. Okay. You have to remove the digit which is in the orphan place or you can remove the digit in the orphan place very easily because it is not being associated with any zeros here. But later on, you are being added with every zero, and the location place has become stronger than the previous place. Okay, that means here it is only 1, here it became 10, here it became 100. So pulling out from 100, 10,000 is little tougher when you take with the comparison of orphan digit. So that is why we take the last digit to be removed from the given number and count it under 1. How should we remove the last digit? When we want to remove this orphan digit, it has to become a remainder. When it want to become a remainder, what is the arithmetic operator which will help us to get the reminders? That is modulo division. We get modulo division. With the help of modulo division, we can remove 2 as a reminder. That means separate 2 from 1432. I will be doing 1432 modulus 10. What happens 1432 modulus 10? This is what happens. That means this become a reminder. Your modulo division symbol will always reposit reminders. Now I have separated 2. Okay. Then because 2 is there, I will count my increment. At the starting, I'll put my counter to be 0. And when I get some reminder, I will increase my counter to be 1. That means I have one digit in my given number. There is a lot of difference between number and a digit. I am talking 2 words. Please cautiously listen what are those 2. Next, I have to change 1432, that is 1432 as 143. Then only 3 will be moving to the 0 position. That means orphan position. So see, to move that into orphan position, see, look into the calculation what we have done. You got 143, but it is in the quotient place. Which is the operator which will help you to record the quotient? That is division. Okay. So I will be performing 1432 division 10. So it results in 143. Now I will change my n value to be 143. Earlier my n value was 1432. Now because I counted 2, I updated my n value to be 143. Right. Now when I take 143, this is the orphan place. I can easily count or remove this orphan place. So as I can easily remove and count, I will be applying the same procedure, that is 143 modulo division 10. Then this 3 will be counted and I will get the counter to be 2 again. I will update my n to be 14. That means I made 4 to be in the orphan position. Then I perform my modulo division and I'll remove that 4. My counter I will increment to 3rd time. Then I'll update my number to be 1. 1 is only in the last position, orphan position. When I do the modulo division, I get 1 as the remainder, 1 with 1, and I count it to be 4th digit. Then n value will become 0 because quotient will become 0. 0 point something, so 0 will be the quotient. When 0 is the quotient, that means I should perform all this activity till my n value is greater than 0. Okay. Then I just got the count of how many digits are there in the given number. Once I get count only, I can go for the next step, that is doing the power. Okay. Let's write for the logic of this counting digits in the given number. Remainder is equal to n percentile 10. I have taken first step. Then I have incremented the counter. When I get the remainder, I will increment the counter. Then I will change, that is update my original number. N is equal to n by 10. These are the 3 steps which will be repeating. How many times it should repeat? Till my n value is greater than 0, I will be repeating. And I will print the count. I have printed the count. Just for understandability purpose, it's actually not required for an Armstrong number, because my actual output for the given question is, that is given problem is, whether it is Armstrong or not. But for our understandability purpose, I am also printing count. That means how many digits are there in the number, whether it has worked properly or not. What is the value of input now? My input was n was 1432, then it got reduced to 143, then it got updated to 114, then it got updated to 0, then it got updated to 0. So now current my original n value changed to 0. So if I want to work something on the n value, can I do something? No, because my n got changed up. Original n value input which I have given is not existing. So what I have to do is, I will reserve and preserve this value. Okay. How do? I will change that value. I will store that value in some other location. Okay. I have to preserve it. So as I have to preserve, I will copy that 1432 in some other location, some other variable, and preserve it, and I do all this functionality so that in future I can use that. So I am doing that with, in the starting itself, I have given k is equal to n. So n value, apart from existing in n as 1432, in k also I am putting that to be 1432. And now I performed all these steps on n. So k has the original value 1432, n doesn't have the original value of 1432 by the end of this. Okay. What's the next step? We have just got factorial, we have just got count of digits in the given number. Now we have to do the power part. How we have to do that power part? Now again I have to start with removing the last digit, that is orphan digit, and doing the power of that digit, add the value to the previous value. Almost same procedure steps happens. R is equal to k percentile 10. Why k? Because previously I have written k is equal to n. N doesn't have any value, k I have the value, right? No, so I can perform only on k, I cannot do it on n. I am doing on k, okay? K percentile 10. R is the reminder I get. Earlier I have mentioned it as reminder, now I am mentioning it as R. This is another part of the program. Sum is equal to, what is sum? First time sum will be 0. For the next step, sum will be previous sum. This is previous sum. 0 plus POW of R. What would be R first time when it is 1432? 2 will be your R. 2, comma, count was how much? 4. This POW is a predefined function. So this part is understood as 2 power 4 by the computer. So 0 plus 2 power 4. Okay. Then I have to update my number to be 143. Then only I can remove 3 and I can do the power. So I am updating the k value to be k by 10. It becomes 143. Now I have to repeat these 3 steps. Okay. Till where I have to repeat these three steps? Again till k is greater than 0. So every time it does as sum is equal to, after this step, sum is equal to 2 power 4, because previous was 2 power 4, POW 1432. So 3 would be your reminder, comma 4. That means sum is equal to 2 power 4 plus 3 power 4. Next step, what happens? Sum is equal to previous sum. Previous sum was 2 power 4 plus 3 power 4 plus the new one, that is power of 1432. 4 will be your next digit, comma 4. So it is 2 power 4 plus 3 power 4 plus 4 power 4. Then sum is equal to previous one plus POW 1 of 4. So this will be added as 1 power 4. All this would be sum, and finally the sum value will be kept as preserved value. Okay. Now same problem occurs again. What is the final k value? K will become 0. Okay. When k becomes 0, do I have the original value? No. That means before I start this process, I have to save this k value in some other location. So I am saving the k value in a z location and I am printing the sum value. Okay. Now where is my value which I have given in as the input? It is in z. First time it was in n. Some performance I have done on n. Before doing the performance, I have saved n value to k. I have applied some performance on k. Before doing the performance, I have saved the value into z. Okay. Now z has my actual value of 1432. These two have become 0 and 0. Okay. Let's write together the whole code to find whether a given number is Armstrong or not. This is your first part, whatever I have explained, which tells about count, starting from k is equal to n to count. This is my second part where I have changed the k value to z and I have performed and I got the output as a sum. Now what I have to compare? What all I have to compare? I should compare sum is equal to z. If my final sum is equal to z, z is the given value now. Both are equal, then I will tell the given number is Armstrong, else it is not an Armstrong. So z double equal to sum. If it is same, then it is an Armstrong, else it is not an Armstrong. For this, my starting point to be your initializations, your main function, count sum to be zeros, and you will be giving your input value n. Now, one point we have to see here, little more. POW is a predefined function, I told. It is a power function which exists and works out if you write hash include math.h, the mathematical header file. Inside this header file, we will have POW. If you don't write this statement, this power function will not get initiated. Let's see the output for this. See here, I have given the input as n value as 143. So first output I got, the number of digits in the given are 3. 1, 2, 3. 3 digits are there in the given number. Then the sum of the digits is 143. Because sum is 143, the given number is an Armstrong. Let's see for another example. N value are exercise example, that is 1432. Number of digits are 4. Sum of the digits is 354. 354 is not equal to 1432. That is why it is not an Armstrong number. Let's see the scenario based question. A recruiter is looking to provide a hike of 2000 added to employee whose rating score is an Armstrong number. Given a score as an input, the recruiter wants the output whether it is an Armstrong or not. So this is the input value, that is n value we will be giving from the keyboard or as an initialization, and they are expecting the different outputs. Let's see, there are two different cases, that is either the value will be, input value will be positive or negative. If it is negative, I have to get the output as error or invalid. If it is positive also, if it is a 0 value also, it is an error and invalid. Apart from that, it may be Armstrong or not an Armstrong. There are three cases. That means I have to club equal to 0 and less than 0. Both are invalid cases. Okay. Let's see the updated code for this. Same first part. Here you see I have written if given n value is equal to 0 or if it is less than 0, it should directly print error or invalid input. Fine till here. And then this is the second part of the code where we have found the powers. Now when I open this else part, where should I close this else part? We feel that we have to close here the else part. What happens if we close there and where actually we have to close the else? Let's see the differences. Okay, I have marked it to the red. We will see where actually we have to put it. This is your comparison part, and actually you have to give your closed bracket of your else here, because After you do all the powers, everything, you have to even work out with your sum is equal to the given number or not. Then only you will tell whether it is an Armstrong or not. Let's see what happens if I put my close bracket here. What type of output we make it? See here, I have given the n value to be 0. I have closed my flower bracket in the starting part, that is here, before my comparison. So, it's clearly giving an output as error or input, invalid input. Till here it is fine. And it is also giving given number is not an Armstrong. So, automatically it is jumping to the given number is not an Armstrong every time. So, as per our test case, we should only get this first part. We are not concerned about this until it is an Armstrong or not. So, my close bracket, I have changed the position of the else close bracket. Let's see. Then it becomes n is equal to 0, error or input, invalid input. See the different output screens. When I give n value to be minus value, this is your expected output and your test case output. When I give positive value, the number of digits are 4, sum of the digits is same, so it is an Armstrong number. When I give 370 as the value, given number is Armstrong. When I give 153, it is given number is Armstrong. Thank you for this session, and these are all the references which I have gone through. Like, share and subscribe for more videos. Thank you all.